Okay, hello and welcome to this video on trigonometric identities for CSEC Add Maths. We'll be starting with May-June 2012. So we have to prove this identity on the screen here, number one. And for proofs, you always want to work with one side, not two. So I'm going to start with the left-hand side and see if I can make that equal to the right-hand side. So just put a little indication that you're working with whatever side. So I'm going to put LHS for left hand side. We're going to say okay. So how am I going to prove this now? So looking at this, the first thing I can see is that this tan theta can be rewritten as sine theta over cosine theta, which is always something you should look out for. Whenever they have like a tan theta somewhere, it's probably good to consider rewriting it. So I'm going to do that. So that's going to be 1 over cos theta plus sine theta over cos theta. Okay, so with that now, you see since we have the same denominator for these two, we can actually rewrite that as one fraction. So we can rewrite this as 1 over 1 plus sine theta. Oops, that's not an S. 1 over sine theta all over cosine theta. So what this allows us to do now is this allows us to just flip this fraction, because we have 1 over a fraction. That means we can just write it as the reciprocal, which is simply cos theta over 1 plus sine theta. So you're probably thinking that's not what they have there on the right hand side. But what we can do with this now is that we can actually multiply it by its conjugate. And what a conjugate is it means that the sign in between the terms, you just change the sign. So basically what I'm going to do is multiply this by 1 minus sine theta. And the reason why we can do that and make it effective is because of the Pythagorean identity, which I'm going to show you in a little bit. So if I multiply this by 1 minus sine theta, I also have to multiply this top part by 1 minus sine theta as well, to make sure that I don't change the value of the fraction. Okay, so I'm just going to work this out in a little corner up here. So 1 minus sine theta times 1 plus sine theta. If you multiply this out, you're going to get 1 minus sine theta plus sine theta, so that's going to cancel. And then you're going to get minus sine squared if you multiply this out. So this is what your product is going to be when you multiply this term and this term. So from this, if you know or if you remember your Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1, then you can see that with a little bit of transposition, 1 minus sine theta is actually going to be equal to cosine squared. Sorry, 1 minus sine squared theta is actually going to be equal to cosine squared theta. So that is going to be really helpful for us in trying to finish proving our identity. So let's do that. So when you do that, you're going to have cos theta times 1 minus sine theta. I'm not going to expand this numerator for a reason that you'll see right now, because if I put this over cos squared theta, which we said is equal to the product of 1 plus sine theta and 1 minus sine theta, you can see that this cos theta is going to cancel with this one down here, because this is cos squared theta. So this is going to leave cos theta in the denominator and 1 minus sine theta in the numerator. And now we have proven our identity. Usually what I would like to do is, or what some other people like to do as well, is write a little therefore proven or QED to just indicate that you have proven your identity. If just for a little background, QED is an abbreviation which stands for quod erat demonstratum, which means it has been proven, essentially. So yeah, you can choose to write whichever one of those you want. Just give a little indication that you have proven identity. Okay, number 2. So number 2 is from May-June 2013, and this is gonna make use of the tan identity. So the information they've given us is that tan theta minus a is equal to 1/2, and tan theta itself has a value of 3. And they want us to use this to find the value of the acute angle A. Okay, so tan theta minus a. So this is making use of the tan compound angle formula, which is for a minus sign in the middle. That's going to be tan A minus tan B all over 1 plus tan A tan B. So we're going to write that out using these values that they have. So tan theta minus A is going to be equal to it's going to be tan theta, that's a theta, minus tan A all over 1 plus tan theta times tan A. Oh boy, that's not an A. Okay, let's just fix that. Alright, that can work. Okay, so now that we have our identity written out, what we can do now is we can say, okay, tan theta is simply just 3, so we can substitute that. So we say 3 minus tan A over 1 plus 3 tan A. Okay, and where do we go from here now? So from here, we know that tan theta minus A, as they gave in the question, is equal to 1/2. So what we can do now is equate that to 1/2. And what this sets up now is this sets up an equation that allows us to solve for tan A, which will in turn allow us to solve for the angle A. So what we're going to do is we're just going to do a little bit of transposition. For lack of space, I won't be showing all the steps of the transposition, but I will be showing the finished product. So we're gonna walk through it now. So we're gonna multiply this. We're gonna do a cross multiplication here. So we're gonna multiply this, the 1 by the 1 plus 3 tan A, and the 2 by the 3 minus tan A. And when you do that, you're going to end up with 1 plus 3 tan A, since that's multiplied by 1, and 6 minus 2 tan A. So we're going to write that now. So that's 1 plus 3 tan A is equal to 6 minus 2 tan A. Okay, so from here what we can do is we can kind of transpose again, move like terms to one side and group them. So we're going to group the tan A's on one side. So if you move this, the negative 2 here, it's going to become a positive 2, so you're going to have 5 tan A. And if you move the 1 to the right hand side, it's going to be 6 minus 1, which is going to give you 5 by itself. And then we can just simply divide out the 5s to leave ourselves with tan A is equal to 1. So if tan A is equal to 1, and as they said it's an acute angle, that means that it has to be in the first quadrant of the unit circle if it's acute, right? Because it's less than 90. And the only angle that's going to be valid for A in this case is going to be 45 degrees, because if you take tan of 45 degrees, that's going to give you 1, which is one of the angles that CSEC actually requires you to know. Yep, for the trig functions, 45 degrees, you're supposed to know the sine 45, the cosine 45, and the tan 45. So this should be no problem for any of you watching this video right now if you covered trig already. So A is 45 degrees. Okay, May, June 2014. So we have another identity to prove here that says that we have to make tan theta sine theta over 1 minus cos theta look like 1 plus 1 over cosine theta. Okay, again, same process. We're going to have to choose a side to work with. And again, I'm going to go with the left hand side because it looks like there's just more information on that side that I can work with. So looking at this, again, I can see that I might want to take that tan theta and change it to a sine theta over cosine theta. So let's just get to work on that. Again, we're going to write that we're using the left hand side just to give them an indication of which side we're using. And we're going to write that sine theta all over cosine theta. Well, not all over, but sine theta over cosine theta, which, if you remember, is actually just tan theta multiplied by sine theta all over 1 minus cos theta. Okay, so where are we gonna go from here? So from here, where I'm thinking we go now is we're going to actually just make this, we're going to make that sine squared at the top, and we're going to rewrite that as 1 minus, cos squared. Actually, sorry, not cos squared, we're going to write that as 1 minus cos squared. So let's just do that now. So since this would be equal to sine squared, we can rewrite that from the Pythagorean identity as 1 minus cos squared. Theta over cos theta. And what we're going to do at the bottom part actually is we're going to just write it like this. You don't have to do this, but I think this makes it look a little easier in my head. So I'm going to write this as 1 minus cos theta over here. because these two are actually equal. Okay, yeah, so we're going to just go ahead and do this now. So what this means is that in my head, I can now see that this 1 minus cos squared theta is just a difference of two squares, which means I can write it as such. I can write this as 1 minus cos theta multiplied by 1 plus cos theta. And that's still over cos theta. And that's still all multiplied by 1 over 1 minus cos theta. But what we can do now is that we can actually cancel something. What we can cancel is we can cancel this 1 minus cos theta with this 1 minus cos theta down here, which is just going to leave us with 1 plus cos theta all over cos theta. And then we can simply just divide these two top terms by the bottom term and split this into the two fractions, since that's what they seem to want on the right hand side. So we're going to say 1 divided by cos theta is obviously just 1 over cos theta, and cos theta divided by cos theta is 1. So clearly we actually have our identity now, which is 1 plus 1 over cos theta. And again, you'd write your QED or proven right after you do this. So this question kind of shows that trig identities tend to be a little bit of creativity, because sometimes you might not do it in the same way that your teacher does it. You might not have even done it the same way I would have done it here. There might be another way to do it, but again, it's just about seeing the different identities. Like this tan theta, I can rewrite that as sine over cosine, or that 1 minus cos squared theta, rewriting it as a difference of two squares. Just remember those identities and just play around with it until you can see a clear way to get to your other side of the identity and get it proven. So yeah, moving on to May June 2015. This one looks very daunting, but it really isn't. So if you just apply the right identities here, you can do this question with absolutely no problem. So again, we're going to pick the left hand side, just because, again, same reason, there's a lot more information to work with, because obviously working with a tan theta, that's not really going to get you much. So yeah, so what do we have? We have sine theta plus sine 2 theta, and we have 1 plus cos theta plus cos 2 theta on the denominator. So the first thing I'm noticing here is that sine 2 theta and that cos 2 theta, I can rewrite both of those in terms of just sine theta and cos theta. So I'm going to go ahead and do that, but I'm going to be very careful about which identity I'm going to choose. I'm going to show you why I'm going to be careful about it. Well, for the cos 2 theta, that is. For the sine 2 theta, I only have one, which is just 2 sine theta cos theta. That's the only one I have for that. So that's all I can do to rewrite this. But that's fine. We can leave that numerator for now. So looking at the denominator, I'm going to be careful about what I choose to rewrite the cos 2 theta as, because remember, cos 2 theta actually has 3 different ways of being written. You can rewrite it as cos squared theta minus sine squared theta. You can rewrite it as 2 cos squared theta minus 1. Or you could rewrite it as 1 minus 2 sine theta. So I'm going to think about which one of those is going to work best for me in this situation. And by the looks of it, I'm thinking that the 2 cos squared theta minus 1 is probably going to be my best bet in this situation. just since I can get rid of that 1 in the denominator by using that -1. So let's rewrite that. So I'm going to rewrite this 1 minus cos squared theta plus 2 cos squared theta. Oops. There we go. 2 cos squared theta minus 1, which is the same as cos 2 theta. So as I was saying before, I can get rid of this 1 with this -1. So that's going to leave us with sine theta plus 2 sine theta cos theta over 2 cos squared theta plus cos theta. Cos squared theta plus cos theta. Oop, that's a little too big. Yeah, boy, it's gonna have to work. Okay. So what we can do now is we can actually look at the top and look at the bottom, and we see that we can actually factor out a sine on the top because sine is common to both terms, and we can factor cosine on the bottom because cosine is common to both terms as well. So let's go ahead and do that. So if we factor out a sine on the top, that's going to leave us with 1 plus 2 cos theta. And we factor out a cosine on the bottom, that's going to leave us with the same thing in the bracket actually, which is cos theta. So factor out the cos theta right here, and that's going to leave us with the same 2 cos theta plus 1, which is the same as 1 plus 2 cos theta. So I'm simply just going to write it like that, just for the sake of being able to see the similarity. Okay, so basically we're finished proving our identity, because this cancels with this on the bottom since those are exactly the same term, and of course sine theta over cos theta is simply tan theta, and that is it. Proven identity. So with this one, you see this one, you just kind of have to think about which of the cos 2 theta identities you want to use. And any questions similar to this, I suggest you do the same thing. You know, think about which identity is best to use, because obviously you're trying to save time in your exam. You don't want to be spending too much time on a trig identities question. Okay, moving on to number 5. So number 5 again requires some compound angle formula, and we have a tan theta plus tan A on the other side. So it's looking like we're gonna have to be using that tan identity again. But yeah, left hand side, because of the same reason, more information. And that's a thing I noticed with CSEC Add Math, is that a lot of the time the left hand side is usually the better side to use, but that doesn't mean that you always have to use it. You can use the right hand side too if you feel more comfortable doing that. Again, it's trig identities, you just do what you're comfortable with. Alright, so sine theta plus alpha, or A. Sometimes I'm going to call it A, sometimes I'm going to call it alpha. It's the same thing. So yeah, I'm going to rewrite this as the expanded version, which is going to be sine theta multiplied by cos alpha plus cos theta multiplied by sine alpha. So this is of course our compound angle formula for sine, which states that sine A plus B is equal to sine A cos B plus cos B sine A. If you don't remember that, it's on your formula sheet, but I suggest that you remember it just to make your life a little easier. So of course that's gonna be still over cos theta cos alpha. So what we can do now is what we've done a few times already, and we can split this fraction into two parts. So upon splitting the fraction, we're gonna end up with sine theta times cos alpha over cos theta cos alpha that's going to be plus cos theta sine alpha over cos theta cos alpha. Okay, so now it looks like there's some cancelling that we can do, which is always lovely to hear. So we can cancel this cos alpha with this cos alpha, and we can also cancel this cos theta with this cos theta. So now things are quite easy for us, because we have a sine theta and a cos theta, and we have a sine alpha over cos alpha, which is of course simply tan theta plus tan alpha. And just like that, we have proven this identity. So this one didn't really take up much lines. I guess that's why they only gave us 3 marks for it. But yeah, again, write your QED or you're therefore proven, whatever you feel like. May, June 2017. So this one looks a little similar to, I think, number 1. So let's see what we can do here. So again, we're going to use the LHS, left hand side, and we are going to go right ahead and get into it. So let's see, what can we do here. So we have a 1, we have a fraction. So what I like to do when I see these is I like to rewrite the 1 in terms of a fraction. So I would want it to have the same denominator as this fraction, right? Which is 1 plus sine theta. And 1 is obviously just 1 plus sine theta over 1 plus sine theta. So I'm going to rewrite that 1 in that way, simply to see if I can notice any easy ways to reduce this. Okay, so once I've done this now, I'll notice that I have a cos squared theta, right? And that cos squared theta is going to allow me to rewrite it in terms of sine theta. How am I going to do that? I'm going to reuse the Pythagorean identity, and I'm going to write it as 1 minus sine squared theta. So since the denominators are now the same, I can just bunch that up into one fraction, and I'm also going to rewrite the cos squared theta as well. So let's just go ahead and do that. That's going to be minus, I'm going to put the bracket here, I'm going to tell you why in a second, 1 minus sine squared theta all over 1 plus sine theta. Okay, so the reason why I have written this bracket is because a lot of times people actually forget that when you subtract a negative, well, you multiply a negative by a negative, it becomes a positive. Not because they don't know it, but because they just forget it's there. But the bracket usually helps me to remember that I'm going to have to do that. So let's go ahead and see what happens now. So if I multiply this negative, you can think of this as a negative 1. So if I multiply negative 1 by 1, I'm going to get negative 1. And if I multiply negative 1 by negative sine squared theta, I'm going to get positive sine squared theta. So that means I'm going to be left with sine squared theta plus sine theta on the top, since that negative 1 and that positive 1 are going to cancel. So this is what I'm left with on the numerator. And that's still over 1 plus sine theta. So what I'm going to do now is I'm going to factor out a sine theta on the top, so we can get that numerator to kind of look like this denominator. I'm going to show you what I mean in a second. So sine theta, if I factor that out on the numerator, I'm going to be left with sine theta plus 1, which is of course the same thing as 1 plus sine theta. I'm just going to write it like how they have it there. Whoops, let me just rewrite that. And by doing that now, you can see I can easily just cancel the denominator and the numerator, which is cancel this and this, and we are left with nice and simple sine theta, which proves our identity. Again, QED or proofing, whatever you want to write. Okay, number 17, May, June 2018. You know, I think they actually repeated a question very similar to this in 2023. Does this paper have 2023? No, it doesn't. But that was the year I did CSEC, and yeah, I believe that it really is a very similar question, if not the exact same. But let's do it all the same. So, proving this identity, May, June 2018. This is one of those questions where I think some people would probably use the right hand side, but I'm going to stick to the left hand side because, again, it looks like there's a bit more numbers, numbers and functions to work with. So what this is that I'm going to make this left hand side into one fraction. So I'm going to cross multiply here and cross multiply here, and I'm going to end up multiplying these two together on the bottom. But what you should notice here is that 1 minus sine x and 1 plus sine x, they're actually conjugates. So you know that if I multiply those together, I'm going to end up with 1 minus sine squared, which is just cos theta. So let's see what we can do with that now. So if we cross multiply, we're going to have 1 plus sine theta, well, not theta in this case, it's actually x. 1 plus sine x minus 1 minus sine x. Again, I'm going to write my brackets so that I don't forget to multiply that negative by the negative. And I'm going to have 1 minus sine x times 1 plus sine x, which is just going to be our conjugate, so I'm going to write it as its value, which is cos squared theta. Or cos squared x. I'm sorry, I keep saying theta. But yeah, if I multiply this negative by 1, that's going to give me negative 1. Multiply the negative by negative sine x, that's going to give me positive sine x. So 1 minus 1, again, is going to cancel. Sine x plus sine x is going to give us 2 sine x on the numerator. And that's over cos squared x. Okay, so we made a good amount of progress on this question just by doing one step. So next thing I'm going to do is I'm going to split this fraction, right? So I'm going to just write this as 2 sine x over cos x, right? And I'm going to multiply that by 1. Well, let me not use the x just to not confuse anybody. I'm going to use a dot, which is in this case is going to represent multiplication. and that's going to be over 1. Sorry, that's going to be multiplied by 1 over cos x, since cos x times cos x is cos squared x. So what we've done is we just split up this cos squared x on the bottom into cos x times cos x, and then I've just put the sine x on one of the cos x is one of the cos x's. And so then that allows us to rewrite this as a tan, right? Because sine over cosine, that's a tan. So that's 2 tan x multiplied by 1 over cos x, which is going to just give us our identity, which is 2 tan x over cos x. So let me just write that really quickly so we can have a good conclusion to the question. 2 tan x over cos x. So yeah, that's number 7. In my opinion, this was one of the simpler ones that they've given, so I'm happy that it came on my exam. But yeah, moving on. Number 8. Oh, this one's actually very simple, very nice. I'm proud of the people who got this question. Very happy for them. So tan squared theta plus 1 is equal to 1 over cos squared theta. Okay. Again, some people might want to use the right hand side for this question, but I'd prefer to use the left again. Yes, I'm a left hand side guy. That just tends to be my side of preference. So yeah, tan squared theta plus 1, what can we do with that? We can rewrite that as sine squared theta over cos squared theta. And then that 1, since I've rewritten this tan squared theta as a fraction, I'm going to write the 1 as a fraction as well with the same denominator, which is cos squared theta over cos squared theta. That's the benefit of having a 1 in your question. When you have a 1, you can always rewrite it as a fraction because the value of 1 can always be represented as a fraction, like so. So what becomes clear to us now is that we have a sine squared theta plus cos squared theta on the top of the fraction, right? And again, since it's the same denominator, we can rewrite that as one fraction by itself, which is sine squared theta plus cos squared theta over cos squared theta. So yeah, that sine squared theta plus cos squared theta on the top, that is literally our Pythagorean identity, which, if you remember, is sine squared theta plus cos squared theta is equal to 1. So just like that, we have proven the identity. There it is. Okay, so number 9. Cos 2 theta is equal to 2 cos squared theta minus 1. So this is one of those ways of writing cos 2 theta that I had talked about earlier. So if this is the last question, I'm actually going to just show you all 3. So they all come from the original one, which is cos squared theta minus sine squared theta. So I believe since it's a 3-mark question, CSEC thinks that we know that. So I'm going to just write LHS again. And that LHS is going to be cos squared theta minus sine squared theta. Oops, that's not a 2. So yeah, we have that. So this is our base identity for cos 2 theta, and I'm gonna just prove the one that they want us to use very quickly. And the way I'm gonna do that is by turning this sine squared theta into 1 minus cos squared theta, again using our Pythagorean identity. So that's going to be cos squared theta minus, again using the brackets so that I don't mess up the multiplication, 1 minus cos squared theta. Okay, so now we're just gonna do some multiplication here. That's going to give us cos squared theta minus 1 minus cos squared theta, which is plus cos squared theta. So actually I'm just going to write that as cos squared theta plus cos squared theta, which is 2 cos squared theta minus 1. So that actually proves identity already. If you got this question in an exam and you didn't feel like you've used enough lines here, you probably just write out that multiplication step and then group it together, but you don't really have to do that. But I suppose if you want to, you can do it. So I'm going to show you the other identity now that comes from this cos squared minus sine squared, and that's the 1 minus 2 sine squared theta. Again, it's similar. You just rewrite the cos squared theta as 1 minus sine squared theta, again using the Pythagorean identity. And you can see how that comes along quite nicely, and that is simply equal to 1 minus 2 sine squared theta. So these are all three ways that you can write cos 2 theta, and again it comes in handy to know these for those identities that might try and trip you up. But yeah, I believe that's it. That's all 9 questions. Do I have any other tips or any other advice for dealing with trig identities? Not really. Again, as I said, I feel like when it comes to trig identities, you just kind of have to think your way through it. Again, just remember your main identities. Remember that tan theta is equal to sine theta over cos theta. Remember the Pythagorean identity, sine squared theta plus cos squared theta is equal to 1. Obviously know how to transpose that. And remember that you can multiply it by the conjugate to get the square of the opposite function. So that means that 1 plus sine theta, if I multiply that by the conjugate, I'm going to get cos squared theta. If I have 1 plus cos squared theta and I multiply by the conjugate, I'm going to get sine squared theta. Once you remember those things, those 4 things, I doubt you can get tripped up by any identity that CSEC Admaths is going to give you, because those are the main things they focus on. So again, it's just about thinking through it, figuring out what you want to do, the way that's easiest for you to and most comfortable for you to do. And yeah, so yeah, I hope this video has helped today. Hope you've at least learned something or figured out a way that you never knew before. And yeah, thank you for watching.